Okay, prove that if S is a root of unity, then the order of S is equal to the order of the inverse of S. So we are looking at 38, page 38, 2.5.13. Okay, so these are the instructions here. And first thing we do is we just say let the order of S be n. And then also it's a little bit of information here that is useful. It kind of ties everything together. N must be the least natural number such that S to the n is 1. All right, because that's the definition of order. If it was not the least one, it would not be the order. Okay, so let the order of S inverse of m, order of S inverse be m, because we can't just assume that they're the same thing right away, where m is the least natural number such that S inverse to the m power is 1. We want to show m is n. So first thing is we already know this. Okay, that was kind of given to us. Then we take a look at S inverse to the m as 1. And then we just take some steps here. Here we just multiply by S to the m on both sides and we end up here. And now immediately you should think, oh yeah, look at that. They're both equal to 1. S to the n is equal to, since they're both equal to 1, then hey, just erase this part, m equals n, right? But not so quick, because they could still be different numbers, right? They could be like, I don't know, like I to the 4th equals I to the 8th, but 4 does not equal 8, right? So let's take a look here. And here, we know that m is the least natural number such that that exists. Then also, I'm looking here now, then also it must be the case that m is also the least natural number such that that exists. And then m is the least natural number such that this exists, and m is the least natural number such that that exists. Now, if m and n are both the least, so let's go here now. So m is 1, s to the m is 1, s to the n is 1, then we know that this is true. But since m and n are both the least natural numbers, then they're both the same number. And so this part is important, this line. We can, since m and n are both the least natural numbers, then they are the same number, and m equals n, which is what we're trying to show.